Hi, this is Will, and I want to talk about my favorite thing for learning about PLCs is factory I/O. And the main thing you can do is you can walk through and step through what steps you need to you know be successful in your programming. And the one I want to do is the pick and place basic. And here is the pick and place. You'll notice, and the way factory I/O is, these arrows are turned on. If we look in the view and we go into dock all tags, by default the emitter and the remover are always on. They're forced on, and we can release these, and you can see the light goes off on the arrow when I change it from forced on to release. And I'm going to do that for both of them. And I think what I want to talk about is, with the pick and place machine, you're moving it, and I can move it just in the Z direction. And one of the things that I'm going to do is I'm going to show some of these things. I'm going to put in play mode here. This is pause, and this is to reset. This is slow motion, and I'm going to use slow motion in the pause to show you what it does. But when you're doing similar movements, and I'll put in movement in the Z direction, and that was a little fast, but it goes down when I turn it on, and when I release it goes back up. Now if I do the same, and I'm going to put in slow motion here so you can see what's going on, if I do the same with the Z, you'll see when I tell it to move in the Z direction, and again, just for clarification, these orange circles are the sensors. The green with the slash in the middle are the actuators. So the actuator I'm forcing on is move, and then this one below it is moving. That is telling you that it's moving in whatever axis I'm in. So right now we went in Z direction to go down and back up. Now we'll go from I guess from this right conveyor, or the input conveyor, towards the output conveyor when I turn it on. So I'm going to force it on with the move in X, and again we're going in slow motion. But you can see as it's moving, this signal went active high, and as soon as it stops moving, I'm going to turn it off. And it takes a little time here to fully come to a stop, but there it stopped. And it does the same with the moving in Z. When it's moving in that axis, it's active high, and then it goes low. And so what we're going to do is, the process is, we drop an item down here, it moves to, and we can turn on, view the sensor tags. But right here, we want to have the conveyor to move until it gets to the items at entry, and then we can use this pick and place to pick it up. And then we'll drop it off here, and when it shows that it's at the item at exit, we'll turn on the conveyor, and then we're going to remove the item. Now what we're going to do is we're going to try to keep it continuously running, so we're going to set it up so the emitter is always on, which it is by default, but we're going to actually control that. And what we're going to do is, because we have this moving in Z and moving in X, rather than use, and again, the control I/O is, if you don't have a PLC, and it's only functional block diagrams, but what we're going to do is we're going to count our steps. So when we first go down, we're going to count to 1. When we go up, it's count to 2. When we move from the input conveyor to the output where it is now, it's count of 3. And then when we drop it on the conveyor, we'll move down, and it'll be a count of 4. We'll move back up, count of 5, and then we'll go back home for a count of 6. And a lot of times when you're doing similar steps or multiple steps, just using a count and an integer value to tell you what step you're on is, a pretty efficient way of doing things. And so we're going to take a look at that. So, and again, so I'll just turn this off for our moving X, and you can see that the moving X signal will go high as soon as I turn this release this, and then it'll turn off when it gets back to the home position. And I've got to unpause it, and you can see that the moving X went high, and as soon as we get back to the home position, it will turn itself off. And another important thing that we're going to kind of hopefully demonstrate is we want to use, and when we get into the control IO, we want to use edge triggers. So we want to use either the rising edge or falling edge. Now for these moving signals, obviously it's active when we're moving, and then it goes inactive. So we want to count on the falling edge. And I have a little bit of a, I don't know, kind of a roadmap. It's a verbal roadmap of what we want to do. But, you know, we start out at the home position, and then when we see the item at the entry sensor, we're going to move in the Z direction, and we're going to go down. Now there's also a sensor signal called item detected. And when we see the item detected, we are going to turn on the actuator that says grab the piece. It's a suction vacuum type thing to grab the piece. And when the move X signal goes from active high to active low, we're immediately going to turn off the moving X so it goes back up. And then when that signal turns back off, we're going to move it from the input conveyor to the output. When it gets to the output conveyor, we're going to move it down, and then, I'm not sure this is a word, but we're going to ungrab the piece. And then we're going to move up, and when it gets back up, we're going to send the piece down the output conveyor, and then we're going to move back home. And again, what we're going to try to do is we're going to try to do this continuously. And so we're going to control the emitter. And the other thing is we're going to control the remover. So what I need to do just to set up is I need another sensor so that when the piece comes down and when it gets to the end of the conveyor, then we're going to turn the remover on. So what we need to do is kind of home in on our sensor, and we'll click on it, hopefully. So to do the clicking on it, we have to be, this is the run mode when this is turned on. We have to be in the edit mode. And the edit mode, it kind of shows you the beam and where the beam extends to. So what we need to do is click on it, then right click on it, and we can go to duplicate. And so what I want to do is I want to duplicate it at the end of the conveyor. So I think I want it right here. And now what I'm going to do, now it has it called the diffuse sensor number 3. If I can home on it correctly, which I still am no good at this. But if I click on that, it'll show up diffuse sensor. And what I'm going to call this sensor is, I'm going to call it the exit chute. I should capitalize that. So when it gets to the exit chute, I'm going to turn on the remover at that point, and then we can control both the emitter and the remover. So it should be in continuous mode, and let's see how we do this. So I'm going to take a little break, and we're going to start up, well, and I guess right now I'm going to start up Control IO. So we go into drivers, and here it asks for what type of driver you have, and normally it's all Allen Bradley or Siemens, but we can also, well, there's a couple Modbus, but we can go into Control IO, and Control IO is the one that if you do not have a PLC, you can use this. And you know, a great thing about Factory IO, and I think it's still true, is you can get a 30-day free trial. So if you like doing this stuff, and they're a great company, you know, get a free trial and try it out. So this is taking a little bit of time, so I'm going to put it on pause, and when we get the control IO fired up, we'll come back. Okay, now this is the control IO, I guess, where you make all the logic. And here you have sources. The main thing that we're going to use are tags. We're also going to need some memories. And memories are like internal bits that we're going to use. And the other main thing is we're going to use function blocks. So let's take a look at what we've got. And all the tags are in alphabetical order. So, the first thing we want to do is we want to put in our start-stop logic. So there's our start, there's our stop. Now, this is in pause, but if I put it into run mode, we can see that stop has that LED lit. And you can also see, because I have it framed around the factory IO stuff, but you can see this is active high. So to get it where we need to be to use it, we've got to go into our logic and we've got to invert that signal. So we're going to invert that, and you got to get used to kind of lining it, but I kind of like the way it kind of creates a little spaghetti there. And what we want to do is we want to go and we want to use, and we're going to use it a lot, and you should use it a lot. These are really good. These are set reset flip-flops. Now these set reset, when the start goes to a logic 1, the output is going to be a 1. Now if the reset goes to a 1, it's going to go back to a 0. Now the thing of it is, they have a reset set, which you can tell that the reset is dominant because there's a little 1 afterwards. So if they're both 1 at the same time, the output's going to be 0. Now they also have a set reset flip-flop, and I'll just bring it up here, and you can see here it's set 1, which means if they're both 1s, the output will be a 1. Now typically you want the reset to be dominant, so you want the top one here, the reset set, and in pretty much all cases. I mean, I would never use anything that's not that. So for our output here, what I want to do, and I'm going to have to go up to these memories because I want an internal memory, and I want it to be a bool, and I'll just pull it out here. And this is going to be my start process. So anytime I'm in start mode, or some people call it system run, I want to know that, and it's not an external bit, so I need to create kind of an internal bit. So if I click on this, it'll ask for what your name is, and I'm just going to put in, and I always call it start process. It doesn't necessarily mean things are running, but it just means, it's the start button has been pressed. And because we say that anytime we're in start, we want the emitter to be on, I'm just going to Control Z, move it over, and Control V. And what we're going to do is we're going to look at our output for the emitter, and we're going to grab that guy and put him over here. So anytime this is on, this is going to be on. And if you're not familiar with the factory IO, the inputs, so the sensors, are all shown in green. The outputs, which the emitter is an output, is going to be in red. So that's kind of the way you need to take your cue. Now what we said is we're going to turn on our entry conveyor anytime that the emitter is on, which means anytime that the start process is turned on. So, and then we're going to turn it off when we get to the point of the item is at entry. So we're going to put the item at entry down here. Now again, when it's at the entry, it goes high. So what we want is we want to combine it with this signal, but we need the not signal. So we're going to invert this signal, put them in here, and then we're going to put it through a 2-end AND gate. And the 2-end AND gate will be this and this. So if we're not at the entry point, which means we're coming down the conveyor, we want the conveyor to be turned on. So this is going to be our entry conveyor. Now as soon as we get to that point, this signal goes high, which means this one at the AND gate goes low, and that turns off our conveyor. And that's pretty much what we need. So the next thing we need to do is we need to start moving the, when it gets to the entry point, we need to move first in the z-axis down, and then we need to pick it up. So let me try to reduce this, move it around. And what we're going to have is, remember, when it gets to the entry, the signal goes high. So what we want is, we want the rising edge of this signal. So when that signal goes to the rising edge, that is when we're going to say, we want to start to move in the Z direction. Now, the way it works out is, and I happen to know this, is we're going to need two things. It's not only going to be when it gets to the item at entry, because when we have the emitter on full time, there's going to almost continuously be a part at that entry signal. So we can't always depend on the rising edge. So for right now, before we put in the other option, we're just going to tie these two together, and that'll work out fine. And what we're going to do in this is, I'm just going to show the start of it because it's not the glamorous part of doing PLC coding, but what we want is when the count equals 0. So I'm also going to go up to our memories, and I'm going to add an integer, and this integer I'm just going to call the move count. So if I click on him, I can give him a name, and it'll be the move count. And remember, we're counting from 0 to 6. 0 is back home, and when we finally finish the cycle, then 6 is the end of the cycle. So that's going to be what we're going to put in a counter. And the other thing we need, if I can find it, is we need this thing called sources. So the source is going to be a numerical, and when we say that the count is 0 and our item is an entry, we are going to move in the X direction. And so we've got that, and these two conditions need to be met. So we're going to go down to our function blocks, and we're going to say we need a 2 AND, because both these have to be true. So we have to be, so we have to be at the entry as soon as we're at the entry, and we need to be at a count of 0. And that's going to be the condition that's going to have us move in the Z direction. Now, we're also going to have, we're going to have to do that a couple times. So we have it when the count is 0, and then we're also going to have it when the count is, I think 3, is we're going to have to go down again. So we're also going to put, and again for the time being, I'm just going to put an OR gate in here, and I can kind of combine these two for the time being. And that'll be my OR gate. And then what we want to do is we want to put in another reset set. And we'll put that in there, and then this will be for our move in the Z direction. And what we're going to do to stop it, remember, we're going down when the count is 0, and then we're going up after we've counted and our count is 1. So I can kind of copy this. I'll just do Control C, Control V. And I can just highlight that and make it a 1. And again, I want to use my comparator signal or my relational, and we'll put that there. So now when that count, my move count, is at 1, and again what I'm going to need is, now this one has an AND gate because it needs both conditions to start the move, but this one I only need to be at the count of 1 when I want it to go up. Now it has to go up a couple times, so I'm still going to need my OR gate. So again, I'm going to do the same thing and just put that there and that there, and then this guy will be to turn it off. Now this is kind of getting pretty long, and to put these in takes a little bit of time. So what we're going to do is we're going to try to run this and see what it looks like in our factory IO. Now we should see a piece of an object going down, and it should get to the stop point. But what we're not going to see, because I haven't put in my grab circuit, but we should see the pick and place go down and then go back up. And let's take a look. So if I go out here, and here's my start stop control panel, and put in run mode, okay, and it's in slow motion, so I'm going to speed it up. So it's going down here. When it gets to this point, it should stop, should go down, and it does not go back up. So let's see why that is. Oh, well, because we don't have our counter in place. So that's the problem. When we go back in here, and let me go back into the factory IO as background, what we need to do is we need to count. So when that signal for the moving X, moving Z, when that signal turned off, we need it to count. So what I'm going to do is I'm going to put in all the comparisons for what we need. I'm going to put in our counter, and we're going to take a look. But as you can see from right here, this is going to put in multiple objects at a time. So we need to keep it going and have it run fast so it can pick up all objects. Now, one of the things that factory IO does not do is it's not going to put objects right on top of each other. So if you turn off the entry conveyor, it kind of throttles down the emitter. So I'll be back in a little bit and we can take a look at what we have. Okay, so let's see what we came up with. So what went into the logic, and let's try to zoom it up here and move a little bit. So we have our start and stop in our entry conveyor logic, and then when we have a part at the entry, and then I'll describe this end of cycle reset in a second. But when the count is 0, we want to move in the Z direction, and also when the count is 3. Now we want to go out of that when the count is 1. We want to go back up, and also when the count is 4. So it's just 0 is down, 1 is up, 3 is down, 4 is up. Now for the Z axis, it's going to be 2 moves from the entry conveyor to the exit conveyor, and then 5 is from the exit back to the home position. And then we have our grab logic. So when we detect an item and we also have a count of 0, we're going to grab it. Now we're going to reset it when the count is 4. So again, it's 1, 2, over is 3 and back down is 4. So when it goes back down on the z-axis the second time, we let it go. And that's also when we turn on our exit conveyor. And down here, beneath the grab logic, we have some of the remover logic. And I wish I could control this better. But we have the remover logic, which says when we're at the exit chute, we use a T-off timer. And, you know, we usually use T-on timers all the time, but T-off is good for if it goes past a sensor, we want that actuator, whatever it is, and it happens to be the remover, we want it on after we pass that sensor for an additional 1 second. And we also use that signal to count our counter, and this is the counter that says how many parts we've processed. And then, you know, for the count, for our count of what we're doing for the moving X's or Z's, either one of these falling edges, because when it's in the moving condition, it's active high. So as soon as it stops moving, it goes active low, which is the falling edge. So when we see those falling edge, we start our count. And again, we count from 1 to 6. Now this end of cycle reset, what we've got there is when the count equals 6, we send that's the end of the cycle, and we're resetting on that. And the reason we do that is because, at least in the way I had done it initially, is if we look at this, you know, when we say that when the item is at the entry, well, I guess it could work either way. When the item is at the entry just sitting there, or when the count has reset at the end of 6, it's going to move in the Z direction. I'm not sure that this is really redundant. I think initially I kind of had this as a rising edge, and because the boxes were coming down and sitting there stationary, we would have needed this, but I think I got rid of that rising edge. Anyway, let's take a look. Let's unpause this and take a look at what we've got. And again, it should be, and I'll reset it here, and we'll go into here. Now our count is at 0, and you should see it come down, grab the box, it'll move it over, drop it down, and then take it off. Now the other box is already waiting there, so it's just a continuous motion. And again, the way the and you can see the remover is off until it passes the sensor, and then it turns on for a second and then turns back off. And you can see that when the entry conveyor is turned off, you know, it kind of throttles down the emitter, so it doesn't keep putting parts on top of each other while the conveyor is not moving. So this is pretty efficient. I think if you use the counters, even though it takes a lot of time to set up the counters and the comparison values, it's a fairly good way to do it if you're, you know, if you're just moving on these axes. So you can count the number of moves, and based on that count, you can determine what you need to do. Now, you know, as we always say, there's at least half a dozen different ways to do it, and I think this is pretty effective. But as I was making this, I was thinking, you know, I should try this with an actual MicroLogix Allen Bradley type PLC where we can only use ladder logic and see how that works out. And then I can also use one of my Siemens S7 1200s, which allow you to even use a higher level language, and that should actually work out to be a higher level of, you know, they call it structured coded text or structured text, and I think that'll work out pretty good. So I think I'm going to try to do those two, but yeah, this one is kind of running out of its limits, so I'm going to let